Okay, so what I'm gonna talk about is the story of gravity, I guess, and how just the history of what we know about gravity throughout history. And so I talked a little bit about this in my last law school seminar with the whole wheel and all that, but I don't think I touched as much I wanted to on the gravity thing because of time's sake, and I just didn't want to just talk about the story of gravity because that'll take up too much time. And so I thought it would be a good idea to talk to you guys in the algebra class because it's all about math with gravity, and so I think it was a good way to just talk about gravity in this kind of setting with you guys with math. I didn't want to really talk about equations and stuff like that because that'll be pretty boring for you guys, and so I think this will be fun and more interesting for you guys. So, who knows here who came up with the idea of gravity? I think everybody knows that, right?
Newton.
Yeah, there you go. Austin.
Sir Isaac Newton.
Yes. There you go. Yeah. And
Whoa.
so,
Austin answered that?
yeah, I know he's on top of his game today. So Isaac Newton, as all of you guys know, is the one who came up with the concept of gravity. You know, the famous story of the apple falling on his head, and he's like, oh wow, this is a force that I can really get used to. And so he came up with the idea of gravity, and he was so smart that he came up with he invented a whole subject to describe the movement of gravity, which is now known as calculus. And so just overnight he created a subject called calculus, and he used it to explain the movement of our planets. And so all of the planet in our solar system is bounded by the force of gravity, and he used calculus in order to explain the movement of those planets. And the greatest mystery of Isaac Newton, though, is he didn't know where gravity came from. You guys probably remember this, me talking about this 2 weeks ago. He died without an explanation of where gravity came from and what caused gravity. And it wasn't solved until 200 years later, after a guy, a really famous scientist again, Austin.
Albert Einstein.
There you go.
Austin!
Wow. You know it's bad when people get surprised that you know Albert Einstein. And so, yes, Albert Einstein came up with the idea. He came up with the theory of the explanation of gravity. And so so the mystery was solved after 200 years after Newton's death. And the whole story of him coming up with the idea of this theory to explain gravity, and the story of him of scientists trying to solve his theory into an actual fact is a very fun story. Actually, it has a lot of ups and downs, and it was really interesting. And I got this from a documentary of Albert Einstein's life, and it was really interesting, so I wanted to share it with you guys. And so, in the year 1905, Einstein published the famous general relativity that gave the fundamental idea of how gravity worked and the cause of gravity. And so, what he said was, so his whole idea of general relativity is that we live in a plane right here, so that's our universe. Right there, that's our universe. Let's say that's our universe. Anything that has mass, so if there's a planet like there, it will bend space like that. It will bend it like that. And so anything that's near that planet is gonna go towards that planet, right? So if I'm here, I'm gonna fall down to this bended space, right? That makes sense to all you guys, right? So, and that's the force, and that's basically his explanation of why gravity was a thing. It's the bending of the space that caused everything to go into something that has mass. And so, you have mass, I have mass. I think I talked about this in the seminar as well. And so, everything that has mass will have gravity. And the way that he explained this changed how people looked at gravity and it changed how people thought about the universe as well. You know, they didn't really have a notion of how the universe was kept in place, but this idea explained it, and they're shocked. And frankly, this was the only explanation that scientists had at the time of gravity, and so this was a very big deal. And so at the time, people were like, hey, let's not leave this as a theory, let's actually have physical proof of that big mass, like planets, can bend space, like can actually bend space. And so what's the biggest thing that you can find around you that you think will have gravity? Like an actual gravitational pull.
Not the Earth.
Yeah, but not the Earth, because you're on it, so you can't really test anything on it, right? So what's around you that has a big enough mass that you can do stuff, like, you know, do an experiment on?
Wait, what do you mean?
I don't think there's
Like
anything
something
big
that
enough.
defies gravity?
Think outside of the box. Think bigger than Earth.
The sun.
There you go, the
Oh.
sun, right? And so the next thing that scientists did is they looked at the sun. And so I'm going to use the red one because it's the sun. And so let's say this is the sun right here, and there's another star out here that's like 20 million light years away. So it's very far away, and it's shooting its light towards Earth, and it's going behind the sun. And so as it's traveling across the sun into the Earth, what do you think that light is going to do? It's going to bend, right? And so what scientists thought of doing is, hey, let's study the light that we can get from behind the sun and see if that bends, and that'll prove if Einstein's theory is correct or not. And so the thing is, that was like 100 years ago. And they didn't have powerful enough telescopes to look at an actual sun and be like, hey, I can see another light source that's being emitted from this very bright sun. So what do you think the next step that they took in order to get the light that was behind the sun? What do you think would help this? Austin?
Oh, I don't know, but isn't the only thing strong enough to bend light are black holes?
Yes, black holes can bend. Actually, black holes eat up the light, and that's
Yeah.
why they're called black holes,
Yeah,
because
but-
you can't actually see them.
Well, I mean,
But anything that has mass technically can bend light,
but just not as visible
Yes.
as black holes.
Yes. or the sun.
Okay.
Yeah, and the sun also bends the light very, very slightly. So, but the only way that you can clearly see it with your with your eyes are black holes, and that's why people would say it. But anything that actually has mass can be calculated to bend light. Yeah.
Oh, I don't know, maybe space shuttles?
They didn't have space shuttles back then. So what's the one thing that can block out the sun?
The moon.
There you go. So they waited for a solar eclipse. That's what they waited for. And so if the moon will cover up the sun, they'll be able to. The sun will be dark enough for them to photograph the sun and calculate the stars that were behind the sun. And so that's what they did. And this is why it took so long for them to actually prove the theory were correct, because you don't really get solar eclipse that often. And most of them, I heard that 60% of them happens on not on land, but on oceans. And so it was hard for them, and back then war was going on, and so it was hard for them to move to another country, photograph a solar eclipse, hope for the sky to clear up when it actually happened. And so it took a couple of decades. It actually took 3 decades for them to actually get a good photograph of the sun. And they took shadow pictures, and so it covered up all the light that was being emitted, so the actual light will look dark in the picture, and anything that's covered will look bright. And so they calculated the dots, which were big stars that were being behind the sun, and they saw that, and they calculated the bend of the light that they saw from the other stars, and they plugged into his little equation of general relativity, and they proved it to be correct. And that's how we know that's how general relativity right now still stands as a theory and as an actual factual thing that's proven to be right. And we can actually see a lot more examples of general relativity in our lives, like the space shuttles that are up in the sky right now, because they get less gravitational pull than we do back on Earth, they are, I don't know, like a seventh of a second more younger when they come back down if they spend 1 year above than all of us. And so, yeah, that's proof of general relativity. And general relativity is very complicated to understand, but I think if you look at it like this way, like looking at it in stars and sun and calculating other things, I think anybody can understand it, and I think that's why I love this kind of stuff, is, you know, being able to teach other people about things that might first seem very complicated, but being able to explain them in a simple term like this is, you know, it makes sense, and I think it's very fun to do that, and I think that's why I wanted to tell you guys about this kind of stuff. So, yeah. Do you guys have any questions? Did you guys like that story? Was that a fun story?
Yeah.
Thank you, Rebecca.